All right, welcome everybody to the platform sprint review. What we are going to talk about the updates from the past 2 weeks, and we are here with the 5 platform teams. Am I sharing my screen? So we are planning this session for about 1 hour. And we are going to give you a quick update on the things we are doing. And actually, we would like to ask you to participate in this conversation and raise your question. Also include the context in your question, because we are going to read them at the very end when we will have a Q&A session. So without further ado, I give it to Dima.
Hi, everyone. My name is Dmitry. I am software engineer at Tenderdash team. And at this moment, our team is on same block execution task. And this is a goal for our next several sprints, I guess. Well, let me do quick overview about what is the same block execution. So currently, Tendermint uses a next block execution approach. It means, for instance, the app hash and proofs for a block committed at height n will appear in state only in the block at height n+1. And it means every block n contains app hash and proofs for a block committed at n-1. So basically, we have like a chain data. And it's not efficient behavior. And so Tendermint introduced a new approach called same block execution, where we don't need to wait for n+1 block to get this necessary information for us, like app hash and proofs. And yeah, it just allows us to execute the block immediately and commit block n with app hash and proofs for block n. So this is a reason why we're on this task. And unfortunately, Tendermint didn't deliver this feature yet. Only specification and the ABCI++ that was already backported previously. Just to remind, ABCI++ is the first part of this improvement. And since we cannot wait for Tendermint, when Tendermint will add this feature, we decided to do it by ourselves. Yeah, this is the reason why we are working on it. And yeah, the benefits which we will achieve it, first of all, we reduce a lot for I/O. We also reduce time assertion data and other stuff which kind of probably most related to the internal implementation and how it works internally. We don't need to spend a lot of time for waiting something kind of redundant, producing redundant blocks. Yeah, let's go next. Yeah, what we planned. Also, we planned for the previous sprint update what extension specification part for ABCI++. This is already done, basically. I was on vacation, this task was on me. I was on vacation for previous couple of weeks and didn't touch it yet. Well, the validator key verification also in review, and we have a plan to finalize both these topics in the sprint. Yeah, we can move forward. Well, yeah, I already mentioned about same block execution, and now about backport remaining code from Tendermint master. So basically, this task is already in progress. We decided to backport kind of partially, do it repeatedly, like pull the changes which Tendermint committed in master, merged, sorry, in master, and we decided to do it periodically, and the time is coming to do it. But also, we got a bad news from a Tendermint team about supporting and development V035 and V033 releases. which Tendermint discontinued due to unstable network, like a P2P layer. And this is quite bad news for us because we already backported both versions in the Tenderdash, and we decided to stay, despite on this decision from Tendermint team, they decided to roll back to version v0.34. Our team decided to stay on the changes which were already backported, and we decided to will fix this issue afterwards if it will be needed for, and yeah, this is kind of bad news which I already also want to highlight. That's all.
Thank you very much. Hand it over to Evgeny. I cannot hear you, Evgeny. Maybe it's me.
It's not you. Evgeny, wake up. Oh, no. Evgeny, we can't hear you. You must have a mic issue. But why don't we move on to wisdom, and then we'll go back to Evgeny.
Maybe.
Now.
Oh,
Now
there we go.
I didn't change anything. Okay, nice. Can you still hear me?
Yeah,
Yes.
don't let your cat walk on your keyboard.
Okay, cool. Okay, we had two tasks. First one was worst case cost continuation, because it's huge, and Wisdom will elaborate more on that. And GrooveDB chunking feature. It is done, and I have a demo for that. So let me share my screen. Please let me know if there are some issues.
We can see it.
Great. How to hide this menu? Okay. I have 3 terminals, and each one will present a different instance of my demo application. A quick note here, it's not how replication will be implemented in platform. It's just a show of application of GrooveDB current capabilities, and especially its chunking features. So it's a web application with some keyboard input, and each of them will connect to each other using HTTP. So let me open an empty database. It's on the left, and as you can see, root hash is zeros. It means that DB is empty, and I fill it with generated data. Now hash is different, and also let me insert some element just to be sure that spot like that it's alive. So because data is random, and after replicating, I need to check it. Yeah, I can have it. And on another node, well, not node, but instance of application, let's open database 2. It will be empty, and we want it to be replicated from the network. So at the peer is just another instance of application. It will be on different port. We added that, and now we want to replicate it. It expects a root hash, and because we cannot just trust every peer we have in network, and we need to check it, and root hash should be taken from consensus, but this time I have my own consensus type called clipboard, so I just copy it. Don't do that on production. And oh, because it's different. Yeah, sorry. I insert an element that should be different. Let's try it again. Okay, the proper hash this time, and it requests chunks one after another, and it's done. So the root hash should be the same, and to ensure that it's actually the same database, let's get an element that we inserted by our human readable name. Yeah, it's here. And let's proceed to a third instance and open a database here too. Should be empty, and let's add 2 peers, because how it will work in Dash platform, it will take chunks from multiple peers, not just one. Yeah, I need to show that. And another peer. It's on the same computer because I have only one computer working right now. But it should work on over LAN network too. We didn't check it. So different ports, different peers, and yeah, it's still empty, and we want to replicate. Still need the root hash, will be the same. And as you can see, it takes chunks from 2 peers, and it's done. And let's do the same test, and it's here. And also, it should validate on the fly, because we don't want to bother network with some malicious data. And let's open another database. It will be empty. Peers are already here. Let's replicate it with a battle hash. Let's change 0 to 1. And it failed because proof did not match. Yeah, that's it. This simple application of GroveDB chunking capabilities. Thanks for watching.
I would like to say a few things. That's amazing. Second, your terminal demos look so much better than mine. I think that you're gonna have to help improve the terminal experience on.
Honestly, you were an inspiration. I looked at your demos and I decided that I want mine too.
Yeah, but yours are just better. Anyways, so that's one thing. The other thing is I would like to talk really quickly about why this is needed, why we're doing this chunking, and why we are moving from like why this work was done. Basically, when you're at a certain level, when the chain has already progressed to a certain amount, let's say you're 1 million blocks in and one node starts running platform. Going through 1 million blocks takes a long time. Replicating the state, on the other hand, takes a significant less amount of time, especially because it's already assigned. So basically the way it works is it just, through a P2P mechanisms, asks the network for different state data, and it gets it a little bit like how it, maybe people are familiar with how a torrent would work, or anything that's P2P, and basically requests it from multiple nodes at the same time, so it can very quickly come up to date. And basically that is what we just saw, not going through platform, but on the very lower layer. And that is really great that is now done. It's one of the last things that we needed to do for GroveDB for mainnet. Okay, Wisdom.
Hey guys, this is Wisdom. Amazing demo again. I was just mining throughout. So the other thing we worked on was the worst case cost. For Dash platform, we took the approach of telling the user the worst case fee that they'll have to pay for an operation, so that they don't go midway and then run out of gas or something, and then they have to cancel their operation and lose whatever they gave as the initial fee. So accuracy for this is really important in order to make sure that we are actually giving the worst case cost. So no operation can be created that will have a cost higher than the worst case cost. And accuracy is also important for being as close to the actual cost as possible. So we don't want a situation whereby the worst case cost is so much larger than the actual cost that it becomes prohibitive also. So this, we are still working on it. It's quite hard to get very accurate, but then we would complete it, and it's one of the last things we have to do for Growth TV. So we're going to continue with this sprint. So what's next? So we're going to continue with the worst case cost. And then we're also going to work on efficient references. So efficient references are going to lead to less storage cost overall, because we're not going to be using the absolute parts for references, and we're going to be using a relative like parts. So once we measure the cost, then we implement this, and then we see the improvements in storage cost also. So yeah, that's it from Growth TV. Thanks.
Thank you very much, Igor.
Hey everyone, my name is Igor. I'm engineer at SDK team, and I would like to share our accomplishments for the past sprint. The sprint goals were to continue on headers chain synchronization process refactoring and SDK documentation updates. SDK documentation update is done, and I will share my progress regarding the headers sync. A quick reminder what I was doing for the past couple of weeks. We are making Dash wallet in the browser to be a fully functioning SPD client, which means that it has to synchronize the whole chain from block 1, pick all transactions, and verify them against Merkle blocks, and so on and so forth. Yeah, so I finished the main module for header synchronization in the wallet library, tested it with one DAPI stream, and actually with multiple streams as well, but it's not covered by integration test yet. I implemented a demo proof of concept to show how it works, and started working on unit and integration tests heavily, because it wasn't possible to test this by hand anymore. So let me share my screen. Balazs, could you please turn this one off? Okay. Actually, one sec. I need to share browser only. All right, so here's a small and simple front-end application, which illustrates how the synchronization process is going in the wallet library. You could see the two sections, one section with the header synchronization progress, and a second section with the transaction synchronization process. So for now, I will illustrate 3 different wallets to you to show how it operates in 3 different states, like header sync, transaction sync, and when everything is actually synchronized. I prepare them because this process could take a while, so it's better to watch something already synchronized partially up to a certain point. So let me start with the first wallet, which is which is a fresh one. Nothing is in the storage yet, and nothing has been synchronized at all. It needs a couple of seconds to kickstart. Yeah, at the right side, you could see our block header streams, and here you could see the progress, how things are going on. Blue circle indicates unconfirmed progress, and green circle indicates confirmed progress. And here at the bottom, you could see the amount of headers which actually has been fetched from the network. Some of them are just stored as orphan chunks currently. And once all of them will be loaded, they will assemble in one verified chain. So that goes pretty quick. Let's just wait a couple of more seconds. and see what happens after I refresh the page. All right, 29% confirmed. Yeah, okay, so header sync is done. And now application starts following the transaction synchronization process. Here you could see how many blocks we already passed and the amount of transactions. Since this is a fresh and brand new wallet, there is no transactions. And let's see what happens after I refresh the page. Let's see how the storage functioning. Okay, so as you can see, wallet loaded from storage, headers all there and verified, and we are on 5% of transaction synchronization process. Let me now illustrate how it works for something heavier. Like we have a faucet wallet, which literally has a single transaction in every block starting from height 300,000, I think, if I'm not mistaken. So this thing is quite huge. And now I will illustrate how it behaves when there are actually some transactions. I partially synchronized this wallet already. Headers are there, and I am on 39% of transactions progress. Let's just quickly connect. And as you see, this wallet already on block 300,000 contains 12,000 transactions. So yeah, this is my favorite edge case, which is super performance intensive for browsers. And eventually, when it synchronizes, it actually might kill browser with the out of memory, kill application with the out of memory error. So memory management in JavaScript in such cases is kind of top thing, unfortunately. So yeah, basically this is how it goes. I'm not holding for too long there. And I will show the last case with the nearly synchronized wallet with 2 transactions. Give me a sec. Yeah, there it is, almost there. So there it is, transaction synchronization nearly ended, 93%. And somewhere at 95, we should get 2 transactions from the network. All right, 94, yeah, here they are. Transactions are all settled, and yeah, we have a balance of $99 million. So this is basically, this is how wallet will be working for users when they first starting the application. Everything is stored into browser or Node.js storage. So the experience should be much more smoother. And you don't have obviously to wait for the whole synchronization every time. This is it. And yep, thanks for the attention.
Thank you very much. One second, and I'm resharing.
Yes, I guess I should also speak about what's coming next. I continue working on this feature. We need to write tests to support multiple parallel streams for block headers, so that it goes really fast. There are some minor tweaks and fine tunings and some unfinished consensus related things in the SPV library we have. I think that next sprint is coming sorry, I wanted to write intermediary, not intermediate. So intermediary QA for part of the feature, manual QA, I mean. And yeah, and integration unit test, of course. So yeah, now this is it.
All right, thank you very much, Igor, for this update and the demo. That's wonderful. All right, shall we jump to the protocol team? Ivan, would you kick us off?
Yeah, hello, that's Ivan Shumkov. So let's talk what we did in the past sprint. Our goal was to prepare the release for 23. We made one more intermediate deployment, release and deployment to the DevNet. Unfortunately, we faced with some bugs. Actually not related to the fee distribution logic, but the new logic uncovered some related problems in the Tenderdash and some drive logic. So we're working on fixing these issues. Also, mobile teams continue to update their code to platform version 23. As far as I know, Android already caught up. Yeah, so, and about the withdrawal transitions, Javid will talk in details.
All right. Hello, Javid here from Platform. Withdrawal transition. So first of all, quick recap. We're doing a special type of state transitions, which will allow you to, identities to withdraw the credits from the platform onto L1 chain. So to get your Dash. So the work is, we've basically split the work into a few parts. The first part is to implement those in Dash platform protocol library. We decided to do that in Rust DPP since we will be transitioning to that in the future, sometime in the future. And to not do the double job, we are doing this in Rust DPP. And this part is actually implemented and right now is in the stage of review. So review, fixes, and back to review cycle. So we still mark it as in progress, but it's close to being done. And our next step will be to implement the part which is located in the drive. So I guess it would be a REST drive and GS drive work after that. And that's kind of it. And I believe next one is Kostya.
Sure. My name is Kostya. I just wanted to mention a few words about the next task. Platform test with browsers test fail with no address error SCI. This is our floating error that we have in CI and it breaks CI from time to time, and we decided to fix it. We've been searching for it during this sprint, and in the end, we found that the issue is envoy related. Seems like something wrong in the config. Yeah, we use envoy to like as a proxy to access to our Node.js code because of security, let's say. Yeah, and we still haven't fixed it yet, but right now we're going to update envoy, update its config, and see how this should help. And I'd like to mention one more thing, that this bug is only reproducible under a Linux environment, and it also makes it a little bit harder to be fixed. Yeah, that's all I wanted to say.
Thank you, Kostya.
Sam. Yeah.
Yes. So one of the things that we now need to do to support withdrawals is to have the special withdrawal of the special asset lock transaction and the credit withdrawal transaction for the library, and we didn't have any special transaction code written in Rust. So that all needed to be implemented. We also didn't have much of Dash core lib, let's say dashified, meaning that, you know, we didn't have those libraries to support Dash core. So that's what I was working on in the last week. I dashified the Dash core lib. This means that you can use it for generating addresses, and also the magic numbers needed for syncing the chain, for creating the Genesis block, for creating, for signing, and many other things. So that was the first thing that's now in review, as well as I implemented all the masternode transactions, which are internally called provider transactions. Those are registration, service, registrar, and revocation, as defined in DIP3. Then the Coinbase transaction as defined in DIP4. And then we have the two that are really needed for withdrawals, for basically the next version of the platform, asset locks and credit withdrawals. And the way that that's going to work is basically platform will ask for these transactions from the Dash core lib, and then we'll sign them through, well, it depends which one, but basically both are needed in this library for the system to work. It was a significant amount of work, though, that wasn't completely known in advance that we needed to do, but you know, it's pretty much done now. So, or it's in review. Hopefully we can get that merged in today or tomorrow.
All right, thank you very much. And a little bit about the plans.
Yeah, so we've been on the fee system for a very long time, and it's constantly the same thing that we're just we don't have a lot of effort going into this right now. Basically, we needed to wait for the GroveDB worst case fees to be done. Wisdom is finishing up on that, and then we can, you know, do the final touches on the fee system. Well, not final, but we can have something working, and then we can ship v23. Yeah, so that's basically where we're on there. We have done a lot of work on withdrawals already. You know, the fee pools, the withdrawal transitions, and we're just going to continue on that work. We also need BLS Rust bindings. This is because a lot of the special transactions that I've implemented require BLS signatures. We don't have any capability to sign in BLS in Rust. And this is actually not only hurting the platform team, but also the mobile team, where some of the new iOS stuff is done in Rust. So this will not be a very intense amount of work, but it will help us going forward. And then, yes, once we have the BLS bindings, we can do BLS payload signing, and that will also help things. The last one is HTTPS for DAPI. This allows DAPI usage in browsers that don't support general HTTP, and it's been a feature that's been requested from the incubator for quite some time, and we're going to start working on it next sprint.
All right, thank you very much. And let's take a look at the Rustport update.
Yep. Hey guys, Anton's here. And today I'm going to give you a little update on Rust DPP porting effort. As it became a tradition, I'm going to mention that everything I'm going to give an update about is related only to the protocol library, to DPP, not the whole platform product. So keep that in mind, please. And yeah, as you can see from this slide, we left about 6% left for full compatibility with V22 when we started the port. And right now, we are actually working in parallel, me and my teammate Pavel, on finishing the V22 and bringing changes from the DPP V23, so we can switch to using DPP in the broader platform, the new DPP ported to Rust. Can you please go to the next slide? Thanks. Yeah. So in the previous sprint, we finished the integration of Rust drive with this new Rust DPP port, and the last sprint, we were working mostly on wrapping up the stuff that's left from V22, which was on the previous slide. And also, we have 17 tasks in total for porting stuff that was added in V23. And 2 of them are currently in review to be merged, and 1 is being actively working on at this moment. And that's the current state. After we finished with all V23 stuff, we're gonna try to test, we're actually gonna test the new Rust DPP with the old JavaScript tests to see that we have full compatibility between 2 versions, between 2 ports. And then we're gonna slowly try to adapt new Rust DPP into the broader platform. And that's update on the Rust DPP port. This sprint, we're gonna work on porting more V23 changes. Hopefully we port a lot more by the end of the sprint. And maybe we even can touch some of the tests that exist right now in JavaScript. Who knows? So we'll see the next sprint. Thank you very much.
All right, thank you very much. And also thanks for the some of your comments and for watching us, as I don't see any questions that we can answer. Asking if anybody else wants to say anything else from the team. Then I would like to thank you guys, for the listeners and the audience for joining us. If you have any more questions, please find us on Discord and Twitter, and see you in 2 weeks.